guys, in last lesson, we looked at finding the probability of multiple events happening at the same time. Those events were independent events. So, therefore, so the outcome of one event did not affect the second one. Now, we're going to look at the dependent probability, which is going to affect the second and the third and the fourth. So, you have dependent events. Exactly what that's talking about. It relies on the first event's outcome to determine the second outcome. Replacement. So when you replace a marble into the bag or whatever, then your denominator is not going to change. That's our first probability there. So this is with replacement. And so then without replacement means that you are not going to replace it. So what happens is that we have that denominator that is going to be a little bit different because we didn't replace the marble or the whatever. So let's look here. So first, for this one, we're always going to assume that you get get whatever probability you're trying to find first. So this notation now, so this piece right here means the probability of A given B, or B given A. So however order you want to look at that. And same thing there, except some of them are the first one is with replacement, and then the second equation is without replacement. So if you remove one, that means your total outcome, you're going to subtract the number of outcome that you removed. And so then it's just going to be 1. Let's look. So this first one, we have a bag of marbles that have red and blue marbles. There's 6 red, 8 blue. If you randomly select 2 marbles with replacement, that means that you're going to select one, look at it, record it, and then put it back, and then select the second one. Find the probabilities of a red and a blue. So this is very similar to what we did yesterday. So we have the probability of a red is going to be 6 out of a total number of marbles, which is 14. And then I'm going to multiply that because I'm going to have a second event occur. I'm going to put it back, and now I'm going to have 8 out of 14. And then I just multiply across here, and I get 0.24, or writing as a percent, that's going to be 24%. So notice that my denominator didn't change there. Now let's look at red and then a red again. So the probability that you get a red the first time is 6 out of 14. But then you put it back, and then you draw another one, and you have a possibility still of 6 over 14. And so that gives you 0.18, or 18%. And then the next one is a probability that you draw a blue and then you draw a red. So the probability that I draw a blue is 8 out of 14. And the probability that I draw a red is 6 out of 14. And then that is going to be equal to 0.24 again. So it's the exact same piece as that. So that's going to be 24%. And then the probability that you draw a blue and a blue. So I'm going to select a blue first, which is 8 out of 14. And then I'll put it back, draw another one, I get 14. Again, and so that is going to give you 0.33, or 33%. And so that's with replacement. Nothing changes. It's just probability, multiply them together. Now what we're going to do is the exact same probabilities that we just did, but this time without replacement. So we're going to find the probability that you select a red and a blue. So the probability that you select a red is 6 out of 14. And then you keep that one out. And so then I'm going to select another one, and I'm going to try to get a blue, which is 8, but I don't have 14 marbles anymore because I kept one out, and that is 13. So then just top times top and bottom times bottom, and you get 0.26 or 26%. And then we have the probability of a red and then a red again. So the probability that I get a red the first time, I've replaced all of them. So don't take like now what's happened from the previous probabilities. Everything's now reset. So I still have 6 out of 14 times. Now I am going to assume I got a red one that time. And so the red now decreases by 1 because now there's only 5 left and there's only 13 left as well. So then multiplying there, you get 0.15 or 15%. Now we're going to look at the probability of a blue and then a red. So the probability that you get a blue is 8 out of 14. And then I'm going to assume that I got a blue. And then the red is 6 out of 13. So then just multiplying straight across there, you get another 26%. And then the probability that you get 2 blues, you're going to multiply. Let's see, blue is 8 out of 14. And then I'm going to assume I got blue. I'm going to subtract 1 from that. And then I'm going to just subtract 1 from the denominator as well. So then multiplying straight across there, I get 0.31 or 31%. So on some of them, the probability went up. And then on some of them, the probability went down, if you'll notice there. All right, so there are 16 students in Mr. Tuff's math class. 4 friends, Chad, Alex, Chris, and Dustin, are all in the same class. He randomly selects 2 students without replacement. So he selects one name, and then he's going to select the next name. And what's the probability that Chad and Dustin both have to answer the question? So we are just going to figure out. There's a Chad. He has a 1 in 16 chance. And then Dustin has a 1 in 15 chance because Mr. Tuff is not putting the name back into the hat or whatever that is. So then multiplying straight across there, you get 0.004 or 0.4%, moving the decimal over 2 places there. So it's very obviously unlikely, but it could happen just because of the number of students in the class. Obviously, the further down that you go down the line, obviously your chances are going to increase. Okay, on example 4, we're going to have that random number generator. It just randomly selects numbers, but this time we tell it not to repeat any numbers. So after it selects a number, it's not, that's kind of scratched out from the number that they can pull from now. So we're going to find the probability that you get an even number and then you get an odd number. So the probability that you get an even number is 10 out of 20. And then the probability that you get an odd number is now 10 out of 19 because it's not going to repeat itself. And so then multiplying straight across there, you're going to get 0.26 or 26%. All right, now we're kind of reset everything. We have a number greater than 15 and a number less than 3. So a larger number and a smaller number. So the probability that you get a 15 is 4 out of 20. And then the probability that you get a number less than 3 is going to be 2 out of 19. And then just multiplying straight across there, you are going to get 0.02 or 2%. So unlikely to get a large and a small, but it's possible. And then we're going to find the probability that you get an even number less than 8. So 2, 4, 6, so 3 out of 20. And then an odd number greater than 12. So 13, 15, 17, 19, because we're only going up to 20. So 4, but that's 4 out of 19. And so therefore we would then multiply straight across and you get 0.07 or 7% there. So dependent probability, the outcome of the first event is going to, or the outcome of the second event depends on the first event's outcome. And so therefore it kind of changes some of your denominators. Remember, you're always assuming that you are going to get the first event actually happens. And that's hard to sometimes wrap your brain around because you're like, well, what if it doesn't happen? But we're going to assume that it does in order to calculate the probability of it happening. We have to assume that we got that first probability had to happen. And so that's it for dependent probability. And now it is your turn to practice with your skill check.